This is Mr. Craig, and this video is to help you name compounds from the given formula. I'm going to have you try to name the formula on your own. You can print the sheet out and try to fill these in, and if you have any discrepancies, then by all means listen to the video. Question number 1 is Na2CrO3. We should recognize that we actually have an ionic compound here, and if we have an ionic compound, we know that it's ionic because we have a metal present. One good thing about the naming compounds in AP chemistry is that we'll never have a metal with another metal. We'll have a nonmetal with a nonmetal, or we'll have a metal with a nonmetal, but we'll never ever have a metal with a metal. So we know that the symbol for Na, or the name for the symbol Na, is sodium. And then the CrO3 is not chromate, which is CrO4 with a -2 charge, but we have one oxygen that's been removed, so this is not chromate with an ATE ending, because then we would have actually 4 oxygens, but it is chromite with an ITE ending. Looking at the second example, SO3, this is not a polyatomic ion here. And one thing that I have noticed throughout the years is students learn their polyatomic ion names, and then I go ahead and throw something that looks like a polyatomic, and they name it as such. One thing that you should recognize is that there's no charge on this compound, and you'll never ever be asked just to name a polyatomic all by itself. It'll always be accompanied with either a metal or nonmetal, respectively. So in this case here, we have a nonmetal with a nonmetal. How do you know you have a nonmetal with a nonmetal? Well, if you take a look at your periodic table, and if you were to draw a line, say from starting with the carbon and going over to the fluorine, and then down to the iodine, and then back to the carbon, what we have just drawn is a nonmetal triangle. In other words, all the nonmetals are touching the triangle lines, or the sides of the lines, and then the sulfur is in the middle of this. Later on, we'll start talking about argon, krypton, and xenon, how they can actually be a nonmetal with nonmetal formula as well, but helium never will. Alright, so let's get back to this. Since this is a nonmetal with a nonmetal, we do not care about charges. Therefore, we must use Greek prefixes to identify how many of each of the elements we have. What we would not do is put mono for the first one. This is simply sulfur. We name the first element as is. Unless there's a subscript, then we would use a Greek prefix to indicate how many we have. Also, there are 3 oxygens here, and I like to hyphenate, and that's fine if you don't. We wouldn't call this Sulfur Tri-Oxygen, but we're going to drop the last syllable, or last 2 in this case, and add IDE. So number 2 is Sulfur Tri-Oxide. Looking at the third example, hopefully you recognize that we have a hydrogen that starts this compound off. Also, hopefully you recognize that there's an oxygen in this compound. So we would not add the word hydro as a prefix in this acid name. But we do have a polyatomic that is very similar. This chlorate ion, the ClO3, has a -1 charge. That's why we have 1 hydrogen, but 2 oxygens have been removed. So therefore, we don't have hydro, but we actually have hypo, because 2 oxygens have been removed. And this is actually from the chlorate ion, but since 2 oxygens have been removed, we call it chlorite. Now, since we have an acid here, we're not going to leave it as ITE ending. We're going to drop the ITE and add OUS, because we have an acid. So if it ends in ITE, you put OUS. If it ends in ATE, you add IC. Example number 4, we have a metal with a nonmetal, and again, it's already bounced out for you, so you don't have to worry about it. And we never ever need to indicate how many of the elements we have to balance this out, because it is ionic. We all know that magnesium has +2 charge. We all know that nitrogen has a -2 charge. So we'll just call it as it is. Except what we don't want to do for the nitrogen is write magnesium nitrogen. we're going to drop the last two syllables and add IDE. So it's nitride. Alright, number 5. We have 3 carbons and 8 hydrogens. This is not tricarbon octahydroxide. This is an organic compound that I had you memorize, or you should be memorizing. The generic equation for this is that I have 3 carbons, and then I'm going to have twice as many hydrogen plus 2. This is known as propane. And it ends in ANE. ANE means that we have twice as many hydrogen plus 2 for the ANE endings. Learn these. If you haven't learned these yet, you need to go to the notes, take a look at the lecture notes from the last PowerPoint that we talked about ever, and review those names. You want to know the ANE endings and the ENE endings. Alright, number 6, AG. Hopefully you recognize that that's silver. Also, silver is one of our transition metals that only has one single charge. It is not a Roman numeral 1. It's just silvers. All silver atoms, when connected to a non-metal, have a +1 charge. And we also have our chlorine atom, but again, we're going to drop INE and put IDE. So this is just simply silver chloride. Number 8, we have a non-metal with a non-metal again from our explanation earlier here. However, we have 4 phosphorus, so we need to use the Greek prefix tetra, and for us, phosphor, us, did I not spell that right? It'd be nice if I had an R in there. It'd be good. Alright, so tetraphosphorus, and again, we don't drop anything at the end there. And then we have 7 chlorines. So 7 is hepta. You may hyphenate or you don't have to. Except we're not going to call it just chlorine, but we're going to drop the INE and put IDE. So P4Cl7 is tetraphosphorus heptachloride. Number 9, we have AlF3, another example of an ionic compound. Aluminum, and then we have 3 fluorines, and again, we don't care about the fact that we have 3 fluorines. Wow, I'm really doing well in spelling today. Okay, so we don't call it aluminum fluorine, but we drop the INE and add IDE. So this is just simply aluminum fluoride. Alright, number 10. This is usually the great problem here. What I want you to recognize in number 10 is that we have nothing but non-metals in this compound. They're all non-metals. However, this is not a molecular compound or a non-metal with a non-metal. I want you to recognize that we actually have 2 polyatomics. We have ammonium, and we have a second polyatomic, which is acetate. So, just like any of the other ionic compounds, and since we have a polyatomic, we don't change anything about this. Whenever you have whenever you have polyatomics, don't change the name, unless there's been some oxygens added or removed. The good news is with acetate, we'll never take any oxygens away. There's no such thing as acetite. I can't even say it. Alright, number 11. We have a non-metal with a non-metal here. And so we're just going to name it. So we have oxygen. And we have 3 chlorines, so it's going to be trichloride. Okay. Again, drop the INE and add IDE. Number 12, we have twice as many hydrogen as we do carbon. So this does not end in ANE, but it actually ends in ENE. 6 carbons, hexa. Okay. So the prefix is hexa, except it's ENE, hexene. For the 6, and that's one of the other, that's an example, one of the ENEs that I want you to memorize. Here we have a metal with a polyatomic, barium, And then IO3 is iodate. Don't change the ending on any of those. Alrighty. Number 14, metal with a nonmetal. So lithium. And then we have phosphorus, but it's just going to be phosphide. If I could spell, it'd be very nice. Okay, phosphide. And then number 15, we have a metal again that's one of the transition metals. However, zinc only has a +2 charge. So we're just going to write it out as zinc sulfate. Number 16 is an interesting example because we have a noble gas in this problem. That's the beauty of having a nonmetal with a nonmetal. We don't care about the charges. So when we look at xenon, we don't have to worry about charges. And we only have one xenon. So you just name it xenon. It's acting like a metal in this case because it's listed first. But the chlorine, we have nonmetal with nonmetal. So we're going to have 4 chlorines. But again, since we want to drop the last syllable or last 2 syllables, we're going to put chloride. 17, you should recognize that we have a metal with a nonmetal, so potassium. And then the CO3 is one of your polyatomics, carbonate. NO2, not a polyatomic. So we just have nitrogen dioxide. Try the last 2 on your own here. We have calcium, and then the ClO4 is a polyatomic, except we've added what? That's right, 1 extra oxygen. So it's not chlorate, but it's perchlorate. And then the last example here is an acid, because we start with a hydrogen, and we have an oxygen, so we're not going to use the hydro. So the polyatomic in this case is acetate, so we're going to call this acetic acid, also known as vinegar. Well, I hope this video has helped out a little bit. I apologize for the inability to spell correctly. And again, this is not a spelling class or an English class, but hopefully the videos helped you to name these compounds a little bit better. If you have any questions, by all means, don't hesitate to ask.